So the next problem that we are going to discuss is, you can locate the problem in your textbook as whatever exercise number or problem number, but that is why I'm writing for you the problem. Okay. The question here is, find the value of m find the value of k, in fact, for which the roots of x square plus 4kx plus k square minus k plus 2 equal to 0 are equal. Just as we had in the above problem, very similar problem. That is, it is given to you that the roots of this equation are equal. So we write the equation first. The given equation is x square plus 4kx plus k square minus k plus 2 equal to 0. Let's call this equation number 1. Okay, and let us proceed to find out the discriminant of this. So here, what is let us find, in order to proceed to find out the discriminant of this, let us find the coefficients. What the coefficients are? Coefficient of x square is a, which is 1. The coefficient of x here is b, which is equal to 4k, and the coefficient and the constant term here is k square minus k plus 2. Okay. So therefore, what is the discriminant? B equal to b square minus 4ac. So here b square is 4k whole square minus 4 into a is 1 and c is k square minus k plus 2. Now we'll simplify this. This becomes 16k square minus 4 times k square minus k plus 2. So this is 16k square minus, open the brackets, 4k square, multiply each term with 4. So this becomes minus 4k square plus 4k minus 8. So this is 16 minus 4 will give you a 12 plus 4k minus 8. Now you see that all the terms have the, what is the HCF of all the terms? HCF of all the terms is 4. So you can take 4 out. You get 3k square plus k minus 2. Okay, this is what you're getting discriminant as. Now it is given to you that the roots of the given equation are equal. So that since the roots of 1 are equal, therefore discriminant must vanish. That is, d is equal to 0. Now what is the value of d here? 4 times k square plus k minus 2 is equal to 0. That means k square plus k minus 2 is equal to 0. Now you can solve this by factorization, I think. K square plus 2k minus k minus 2. That means you get k plus 2 minus 1 into k plus 2 equal to 0. That means you are getting k plus 2 into k minus 1. So that means either k plus 2 is equal to 0 or k minus 1 is equal to 0. Means either k is equal to minus 2 or k is equal to plus 1. Okay, so only for these two values of k, the roots of the given equation here, this will be equal. For all other values of k, we don't know what will be the nature of roots. But definitely we know here that for these two values, k is equal to minus 2 and k is equal to plus 1, the roots of these two will be, this equation will be equal. Now the question is, what will be the equal roots? That you have to put the value of k and solve. we'll see that I have solved that type of problem in your solved problem that I've sent you, the notes. Okay, so we'll see that in the notes. Now we move on to the problem from the notes. So this was a note that I sent you. Okay, and 3-1 I think I've already solved. Okay, so we'll not solve 3-1. 3-1 we have already seen in the first problem that I worked out from nature of fruits. Okay, so we'll move on to 6-2. 6-2, let me just mention the problem here. The problem here, the 6-2 was find the values of m. The question here was find the values of m for which the equation x square plus twice m minus 1 x plus m plus 5 is equal to 0. Okay, you need to find exactly similar problem except that you have a different coefficients here. Okay, and say therefore the simplification will be a little different. So we do it the regular way. So we have the given equation is x square plus twice m minus 1 x plus m plus 5 equal to 0. Call this 1. Okay, so here coefficient of x square a is 1, coefficient of x is twice m minus 1, and the constant term here is m plus 5. We now proceed to find out the discriminant. Therefore d is equal to b square minus 4ac. B square, b here is twice m minus 1. We'll put the entire thing in curly brackets. B square minus 4, a is 1, c is m plus 5. So this is 4 times m minus 1 square minus 4 times m plus 5. Now see how to simplify. First expand by a minus b whole square. M minus 1 can be expanded by a minus b whole square as m square minus 2m plus 1. And for the second one, you open the brackets, you might have minus 4m minus 20. So this is 4m square minus 8m plus 4 minus 4m minus 20. I simplify this. 4m square remains as it is. You have minus 8 and minus 4, which will give you a minus 12m. And you have a plus 4 and minus 20, which will give you a minus 16. Okay, now if you see all the three terms, the HCF of all the three terms is 4, which you can take out. You get m square minus 3m minus 4. Okay, since the roots of 1 are equal, it is given to you that the roots are equal. Since that the roots of 1 are equal, therefore d must be equal to 0. So d here is 4 times m square minus 3m minus 4 is equal to 0. That means you get m square minus 3m minus 4 is equal to 0. That means now you factorize this, you get m square. How do you break a minus 4 in 4 into 2 factors such that the sum is minus 3? Minus 4 plus 1 minus 4m plus m. Okay, now from the first two terms, you take out m. From the next two terms, you can take out 1. And therefore you get m minus 4 into m minus 1 is equal to 0. That means either I'm writing directly here m is equal to 4 or m is equal to 1. Fine. So for these two values of m, you will definitely have the roots of this equation to be equal. For other values, we don't know. Okay. So that is this problem. Now we'll move on to the next problem, and next problem is exactly not exactly, but uh, uh, I mean half similar to this problem, except that in the next problem you will have to not only find the values of p for which the roots are equal, but also to solve the resulting equation. So let's see how to solve. Now in this notes I have given you one method. I will explain another method of solving uh, here. You can do it in two ways actually to solve. So let's see the next problem. Okay, let me write the problem first. The question here is, find the value of p, find the value or values of p for which the quadratic equation 2p plus 1 whole square, 2p plus 1 x square minus 7p plus 2x plus 7p minus 3 is equal to 0 has equal roots. So first part of this problem is this. So what values of p this has equal. So this will be exactly similar. We'll find out the discriminant, put it equal to 0, find out the value. Now what is the next, what is the special part for this problem is that you also have to find out the roots. Also find these roots. What are the equal roots? Okay, so we proceed with the first part. The given equation is two p plus 1 x square minus 7p plus 2 x plus 7p minus 3 equal to 0. Call this 1. So here coefficient of x square a is 2p plus 1. Coefficient of x here is minus 7p plus 2. And the coefficient of c here is 7p minus 3. Okay, so now therefore discriminant, write d equal to b square minus 4ac. B square, b here is minus 7p plus 2. Okay, minus 4. See how I'm writing. Okay, I mean, you need to maintain the brackets, and you need to be very mindful of the brackets and the negative sign. A is 2p plus 1 and c here is 7p minus 3. Okay, so now since I have a negative sign raised to an even power here, so this will become positive. Okay, so this will become simply 7p plus 2 whole square minus 4 times. Now you have these two, you can multiply these two. Okay, so if you multiply these two, you have 14p square minus 6p plus 7p minus 3. Okay, now you can expand 7p plus 2 whole square by a plus b whole square. So this you get 7p square plus twice 2ab term, 2 into 7p into 2 plus 2 square minus 4 times You simplify this, you get 14p square minus 6 plus 7 will give you a plus 1. Okay. So this is 49p square minus 14 into 2 is 28p plus 4. And here you multiply with 4 all the terms inside the brackets. So you get 14 into 4, you get as 56. Yes, 56 p square minus 4p plus 12. Now you see that you have a 49p square minus 56p square. 49p square minus 56p square will give you a minus 7p square. Minus 28 and minus 4p will give you a minus 32p. Okay, and 4 and 12 will give you a 16, right? Let me just see if I have. Okay, so this should be plus. This is a plus sign, so 28 minus 4 will actually give you a 24. 28 minus 4 will give you a 24 with a plus sign. See, this is a plus b whole square formula. Okay, so that is why there's a plus sign here and a plus sign here. So this is what you get. Now, what you can do is you can take, in order to keep 7p square positive, you can take minus sign common out of the bracket. So minus 7p square, since you're taking minus sign out of the bracket, the signs inside the brackets will change. Okay, so you get, this is what the value of the discriminant is. So since the roots of 1 are equal, therefore d must be equal to roots of 1. Therefore d must be equal to 0. Okay, so this is minus of 7p square minus 24p minus 16 must be equal to 0. So this will give you 7p square minus 24p minus 16 equal to 0. Now you simply factorize this into two factors. And what should be the factors? You multiply 16 into 7 first. 16 into 7, see here I've done 16 into 7 is 112. And then what are the factors? 4 and 28, you will see the other factors. Minus 28 and plus 4. Minus 28p plus 4p. If you want, if you can't find the factors, you will solve this quadratic equation by Sridhar Acharya. Okay, if you can't find the factors. So here you have 7p, the p minus 4 plus 4 times p minus 4 equal to 0. That means you get p minus 4 into 7p plus 4 is equal to 0. That means you get either p is equal to 4 or you get p is equal to minus 4 by 7. Now you're getting these two values of p. So the first part of the question is done. The first part of the question stated that what are the values of p. So the two values of p we have already got. Okay, the two values of p we have got as 4 and minus 4 by 7. Now the question is solve this equation also. So we'll have two cases for two different values of p. Okay, so case 1 will be when p is equal to 4. Okay, so from 1, what is your given equation here? Write the given equation. From 1, you have 2p plus 1 x square minus 7p plus 2 x plus 7p minus 3. This was the given equation. Put the value of p here for case 1. That is, put p is equal to 4. So you get twice of 4 plus 1 x square minus 7 into 4 plus 2 x plus 7 into 4 minus 3. equal to 0. Now you simplify this. Okay, you simplify this. See here what I have done. 9x square minus 30x plus 25. Okay, so simplify this, you get this quadratic. Now see here, you, as I told you, when you know that the roots of an equation are equal, you have already shown that for p is equal to 4, the roots of this will be equal. So you can proceed in this manner as I have done here. Okay, this you can factorize this and you can find out the values of x. You can factorize this into a perfect square because you know that the roots of this equation are equal. So that is why if you see it has been factorized into a perfect square. Otherwise, what you can also do is here you can use Sridhar Acharya also, and very easily you will get by Sridhar Acharya. So therefore, x must be equal to minus b. Which one is b? B here is minus 30. So minus of b. Right? Let me write the formula for you. So minus x is equal to minus b plus or minus root over of e square minus 4ac by 2a. But what you see here is that b square minus 4ac is 0, isn't it? Because the roots were equal. D. This discriminant was 0. So this part is 0. So what are you ultimately getting? You're simply getting minus b by 2a. Right? Now you put the value of minus b and 2a. What is minus b? Minus b here is minus 30. So minus of minus 30 divided by 2a. A here is 9. Right? This one is your a. So you get 30 by 18, which is equal to, now you can cancel here with, I think, 3 you cancel, and then you can cancel with 3. 5 by 3. So therefore, what are the equal roots? The equal roots are 5 by 3, 5 by 3. We consider case 2 now. We have solved this equation for p is equal to 4. We consider the next value of when p is equal to minus 4 by 7. Okay. So you put minus 4 by 7 in the given equation as we have done here. Write the equation from 1. Your given equation is 2p plus 1 x square minus 7p plus 2 x plus 7p minus 3 equal to 0. Put p equal to minus 4 by 7 twice minus 4 by 7 plus 1 x square minus 7 times minus 4 by 7 plus 2 have x plus 7 into minus 4 by 7 minus 3, okay, equal to 0. Again, the simplification part, if you see, I have shown you here in the problem. Okay, just go through the simplification part. Okay, you know how to simplify, take LCM of fractions and all. So I'll not do it here. So ultimately, after you simplify, you're going to get minus 1 by 7x square plus 2x minus 7. Yes, plus 2x minus 7 equal to 0. You're getting this quadratic. Now exactly as you had done earlier. Therefore, x is equal to minus b plus or minus root over of b square minus 4ac by 2a. Okay. So now here you know that the discriminant is 0 because the roots are equal. So you simply get minus b by 2a. Now put the values here. Minus b. B here is this 2. So minus 2 by a here is minus 1 by 7. Twice of minus 1 by 7. So in the numerator and denominator, the negative signs cancel. So you get 14 by 2, which is equal to 7. Okay. So here, if you see, you're getting equal roots as for the second case. Here you're getting equal roots as 7. For the first case, you're getting equal roots as 5/3. Hence, the equal roots are, okay, it's been just right here. The equal roots are 7,7. And for the entire problem, hence the equal roots are 5/3, 5/3. For what value of p? This is for p is equal to 4 and 7,7 for p is equal to -4/7. Okay, that's it. That is your solution. Any questions on any step of this problem? I have solved case 1 and case 2 in the note in a different manner. Just go through this. If you understand, very well. Otherwise, you can definitely use this method that I have shown you. Okay. Any questions on this?
No questions, sir.
Okay. So what I'll do is I'll stop here for today.